would be ready in case I could be I could be nicely dressed and wait. And so. But then at 11 minutes after 5, my wife came in with our telephone, our mobile phone, and said, there's a lady with a beautiful voice. She says she's calling from Stockholm. And I didn't hear the ring, and so I got out of the shower. I didn't want to keep her waiting, so I didn't, I just was soaking wet and naked, and took the call, and that was it. But not only didn't I realize that it was going to be earlier than 6 o'clock, I also didn't realize that it was not just a matter of, they say, congratulations, you've won the Nobel Prize, goodbye. It's not it's not that way at all. They say something like that, but then they start telling you about what the ceremonies are going to be, and then the whole bunch of people want to talk to you. The head of the Royal Academy, the secretary of the Academy, friends in the physics world, the people who were on the physics committee. There probably were a dozen different Swedish people who wanted to talk to me, and we talked to them. So, and each one was 4 or 5 minutes. No, that's probably an overestimate. Each one was 2 minutes. Anyway, there I was, still, still naked, still wet. My wife kind of dried me off. But that was the experience. But of course, at that point, I was numb. I was not really aware of my physical condition. It was a fantastic. It's a fantastic thing. It was much more than I anticipated. I anticipated kind of it would be a relief, but it's not. It's much more than that. It's first of all, it's a great party when you go to. It's a whole week of one event after another where you say nothing can top this, and then the next thing tops it, and then there's just such an outpouring of. I guess you could call it, or certain, affection, love, even from my colleagues. That it's not for me personally, some of that, but for the science getting recognition, this field getting recognized, and that there's a community. It's a community, and everybody feels happy about. Even my rivals, and at least they put a good face on it. And then it's really nice to do events like this with the general public and see that the scientific enterprise is really something that a lot of people appreciate and get inspired by. It should be. It should be. I think it should be an even more important part of our culture. Because, it's what makes the difference between all of us being able to sit around here in comfort be on television or whatever, as opposed to being down on the farm struggling for an existence, and that's what really makes the progress of the world. Even if scientists don't capture their fair share of the economic rewards, it's really nice to. It's good to see that there's a community and that there's appreciation and enthusiasm there, as there ought to be. So I think. Mr. Nobel gave a great gift to the world, because it's inevitable, I think, that most people pay for and support and appreciate things that are of immediate benefit to them personally. The things whose benefits are spread over many, many people and may not be obvious for many, many years are harder to appreciate, harder to award. But that's what the Nobel tradition is all about. You know, it's work that is not necessarily going to be of economic benefit to any particular person. And in the case of literature, for instance, so probably not to the economic benefit of anybody, but and most of whose benefit is also in the future, maybe in the far future. So very hard to monetize. But he that this is a recognition for that kind of work, which in the long run is probably what benefits everybody the most.
I'd like to say I'm certainly honored to be able to sit next to you. Now, I didn't plan. I tried to get 3 or 4 guys to sit in there with me. But with that said, certainly want to commend you. I think that's a tremendous accomplishment.
Thank you.
To achieve that. What would you say would be an area that, as far as science, that students should maybe think about or focus on? And that may be kind of broad, but what?
Well, there are many areas. I think developing new materials, which is something that's done here, is a very, very important enterprise. There are new, with our much improved understanding of matter in the 20th century. The possibilities for designing new materials, I think, are more exciting than ever, because we really, it's still somewhat of a black art, but there's more theoretical guidance and genuinely new possibilities about nanomaterials and nanoengineering, so that and of course materials are the basis for everything. A particular challenge that I think is not crazy at all, but where just relatively modest improvements would change the world, is the question of gathering the energy from the sun and turning it into useful forms, so that we could store it and use it for a wide variety of purposes. As I'm sure you all know, we're presently at something of a crisis in energy. It's a slow motion crisis, but it's a very real crisis. That most of the ways we have of generating and using energy involve polluting the environment in various ways, but especially putting carbon dioxide into the atmosphere, which lasts a long time and has already reached historically high levels. I think the current level of carbon dioxide is, I think, the most it's been in tens of millions of years. If not now, then very soon. And tens of millions of years ago is much hotter, partly because of that. But that's on the one hand. On the other hand, the sun's energy that is coming down on the Earth is over 10,000 times what we use. So if we could capture in economical form 1/1000th of that, we'd have 10 times as much energy in a much cleaner way. And I don't think that's crazy. In fact, photocells that we currently have are not that far behind fossil fuels, maybe a factor of 2 in terms of their economics. So that's a concrete challenge that I think is enormously important as a practical matter. There, on another front, I think our silicon technology for information processing, of course, is enormously impressive and has changed the world with computers and communications. But I think it's only the beginning, and it's sort of running into its natural limits. And new chip factories require enormous investments, and you have to throw away most of the product, and also, although it's impressive, it doesn't nearly exhaust the theoretical possibilities for computing. In particular, the chips are basically two-dimensional structures. They have to be fault-free, and they don't use quantum mechanics in a serious way. They're basically classical objects, and all those can be changed, and that is if we can exploit ideas about fault tolerance, ways of architectures that are three-dimensional as well as fault tolerant, things that use, instead of moving around charges, which is basically manipulating electron charges, which is what we do now, and involves a lot of heat, which is a serious limitation. If we could move around spins, or if we could move, or if it could go to really quantum mechanical computing, then we could reach a new level there. So I think there are many possibilities in that direction. And monopoly for a long time. While it was, they had to put a certain amount of their profits into research by law, and that's why there was a Bell Labs, and Bell Labs did some visionary research, developing transistors, developing advanced materials that didn't pay off for many years, and probably would have been difficult to do if it weren't a regulated monopoly, but which made telephone service much cheaper in the long run. Sort of drove AT&T out of business eventually, but from the point of view of consumers, was a tremendous advantage. So long term. It wasn't the government as such, but it was sort of long-term investment that wasn't driven by market forces. The best investment from the point of view of the future and the country as a whole. And I think we should have more of that.
Very diplomatic answer.
Right.
I have a question.
Mm-hmm.
Are you still aggressively pursuing your research now as when you were before you received it?
I'm trying to. Yeah, it's a challenge because I have many more demands on my time. So I fortunately have some very good collaborators and students that work with me. So I'm working in a somewhat different way, sort of farming out calculations that earlier I would have done myself. But I'm also learning to be much more disciplined about how I use my time. But, well, it's tough. It's tough. So things probably move slower than before, and I have to be more selective about how many problems I can work on. And, but